So we've already seen the error in inverse and the condition number. Now we can look at the error in a solution of Ax equal to B. So this is actually an extension of the error in the inverse. Suppose we are supposed to solve X is equal to B, but we don't have access to A. Instead, we have A plus E. So we don't have A. We wanted A, but instead we got A plus E. So ideally, X should be, if A is invertible, X should be A inverse B, right? But we don't have A here. But instead of ending up getting X, what we'll end up getting here is an X cap, which is A plus E the whole inverse into B. So the error now which we have in X, the solution will be X minus X cap, which is actually A inverse minus A inverse, A plus E the whole inverse into B. So we're using similar sort of a setting here, like the last case, like in the error of inverses. And then here we are assuming that the spectral radius of A inverse E is again less than 1. So we can use the infinite sum to represent the inverse. A plus E whole inverse can be represented using an infinite sum. So we use that, and we've already seen this difference, A inverse minus A plus B whole inverse, can be expressed as sigma k equal to 1 to infinity. 1 k equal to 1 to infinity minus 1 raised to k plus 1 A inverse E whole raised to k into A inverse. And since we have a B here, that will be, we also have an A inverse B. So this A inverse B is actually X, which we are supposed to have, right? From here, X is equal to A inverse B. So this is actually X. So here X minus X inverse will be again, sorry, X minus, yeah. Fine. Okay, let's put that as X itself for the time being. Now we take norms like what we've done for the other case as well, and apply sub multiplicativity. So if you take look at the left side, it's a vector norm, and the right side there is a vector as well as a matrix. So here we are using a set of what do you call set of matrix norm and a vector norm, and these vector norm and matrix norm has to be compatible. So what do you mean by compatible is if it satisfies an inequality like norm of AX is actually matrix. It is if it's less than or equal to vector norm of A and vector norm of X, where A vector norm of A is actually the matrix norm and X is again the vector norm. Matrix norm of A into matrix norm of X. If it satisfies this inequality, then it's called the these two norms are said to be compatible. Okay, so we can assume that they're compatible, and we can put this condition, and again we apply sub multiplicativity and all those things. Then we use this is an infinite series, like in the previous case, where that will be A inverse norm of A inverse E divided by 1 minus norm of A inverse E into norm of X. So the relative error here will be norm of X minus X inverse divided by norm of X will be less than or equal to kappa of A, which is the condition number. Kappa of A is the condition number, minus kappa of A into norm of E into norm of A, where the whole thing is multiplied with norm of E into norm of E divided by norm of A. Now this has a slight modification also. This is the case where the right hand side B was non-erroneous. Suppose there is an error in E also, sorry, finding B also. Instead of B, we had a B plus E. Okay, in that case, there's one more term, which is this term will be an additional term, which is kappa of A divided by 1 minus K into norm of E into norm of A, and In the numerator, we'll have vector norm of v divided by vector norm of b. Okay, so that is the error which we have for solutions.